All right, this video is going to cover entropy. So last thing was enthalpy. This is now entropy. So again, enthalpy is the energy change in a reaction. Okay, the heat change. So is it endothermic? Are we adding heat in to make the reaction happen? Or is it exothermic? Are we giving heat off for the reaction to happen? Okay? And that's signified by delta H. Entropy is the amount of disorder in a substance. Now, nature tends to go towards more disorder. You know, if you take a deck of cards that are stacked up nice and drop them on the floor, they tend to spread out into disorder. Okay, they don't tend to go the opposite. If you have a stack of them and you drop them, they don't tend to go into a stack. Okay, so nature tends to go towards disorder. If you got a pile of leaves, they tend to spread out and become more disordered. So same thing with reactions. They tend to go towards a more disordered state. Okay, so delta S is your amount of disorder in a reaction. So if delta S is positive, that means we are increasing in disorder. It means there's more disorder here than here. What we're eventually going to use this for is these two things together will determine if a reaction is spontaneous or not spontaneous, if it occurs naturally or if it is not. So if we have a decrease in disorder, that would mean that these things have more disorder and these have more order in that case. One of the things you'll see, delta H standard, delta S standard. The little knot next to that, a little zero, delta H naught, delta S naught. That little standard sign means we are in 1 molar concentrations if we're doing something aqueous, 1 atmosphere of pressure if we're dealing with gases, 25 degrees Celsius. Okay, so if you see something at standard conditions, that's what they're saying. If it's non-standard, there's some other ways to figure things out, but that's the standard conditions. So let's talk about delta S for a second here. Let's say we have water as a liquid, and it goes to water as a solid. So it would be freezing of water. Okay. So your delta H would be exothermic. You have to remove heat from liquid water. Okay, so it would be exothermic, so delta H would be negative. So many kilojoules. Okay, delta H is in kilojoules per mole. Our delta S, so think about it, there would be a decrease in disorder. In other words, it would become more ordered. A liquid, the molecules are free to spread around. In a solid, they are more rigid. Okay, this is more ordered, liquid is more disordered. So there would be a decrease in disorder, or an increase in order. But think of it as a decrease in disorder. So our delta S would be negative as well. We're going down in disorder. Reactions tend to work better when there's an increase. Okay? This is not spontaneous at room temperature. It does not happen naturally. The opposite does. Heat tends to go into a piece of ice at room temperature and cause more disorder. That'd be a positive delta S going the other way. So again, if this is negative enthalpy this way, it's positive that way. Same thing with disorder. If there's more disorder that way, if there's less disorder that way, there's more disorder this way. Sometimes in reactions you can estimate the disorder or the entropy by counting how many moles there are of reactions and products. It doesn't always work, but a lot of times it does. So here we have 1 mole plus 5 moles. We have 6 moles of reactants producing 7 moles of products. Okay? That's a little bit more disorder, going from 6 moles to 7 moles. So our delta S is probably positive. We're probably increasing in disorder. Well, you can find delta S the same way. There's entropy tables, just like there's enthalpy tables. They are in joules per mole, not in kilojoules per mole. So entropy will be in joules, enthalpy will be in kilojoules. So you got to be careful with those signs when we start using them together. But same thing, I'm going to say sum of the products minus sum of the reactants for my entropies. So 3 moles times that is the entropy of carbon dioxide, plus 4 moles times that entropy, minus that. Notice individual elements do have entropies. O2 has an amount of entropy in it. It has an amount of disorder to it naturally. Okay, they've measured that as a comparison for something else, but it has a certain amount of disorder to it. Typically things that are gases have more disorder. Typically things that are bigger molecules will have more disorder. They have more electrons moving in them. So if we do that for this, our delta S at standard conditions is positive 100.7 joules. That means we're increasing in disorder. Delta S is positive, going from lower disorder to higher disorder there. It is, remember, exothermic, meaning heat is being given off. So as we start talking about reactions being spontaneous or not, we'll take into account both of those things. There will be some problems on Schoology with this video that you need to do as well.